Okay, Assalamualaikum and good day everyone. So for today we're going to discuss on chapter 5, which is planar kinematics of rigid body. So first we begin with discussing on what is a rigid body. So a rigid body, it just means it's a body with a lot of points on it, right? And the distance between these points does not change even if this whole rigid body moves. Meaning the relative distance is the same lah. So it is a rigid thing. If it's not rigid, for example like a slime, so a slime can change its shape, right? So the points, the distance might change, right? So this is not a rigid body lah. So a rigid body, all the points, the relative positions are always the same. So what do we mean by rigid body motion? And what's the difference between what we did before this for chapter 1, 2, 3 and 4? Well, the biggest difference is a rigid body can move in a straight line or in a curved line. Okay, for example, so here is a rigid body that moves in a straight line, and here is a rigid body that moves on a curved line. So it's the same with a particle, right? A particle can move on a straight line, or you can have a particle that is moving along a curve. Right, we did this in the previous chapters, right? The biggest difference is being a rigid body can also have a rotation about a fixed axis, while a particle, if it rotates, what will happen to it? For example, it rotates in this direction, staying in place. Nothing will happen, right? A particle, a point, having a rotation is just staying in place. Nothing happens. But if a rigid body, if it spins, the points on the rigid body, the position will change, right? For example, if it turns 100 degrees, this point here will become here. This point here will become here. So this is what we are going to actually focus on lah, because these two are actually quite similar to a particle as well. And also, if a rigid body is moving with a combination of a curvilinear translation or rectilinear translation with a rotation, this is what we call a general plane motion. For example, here it is moving, but the angle of movement changes, right? So if we try to find how this rigid body angle changes, where is the axis of rotation? Well, because it is changing from here to here, so we can predict that the axis of rotation is somewhere over here, and most probably it changes as the rigid body moves along. So it depends on the movement of the rigid body. So if it's a combination, it's what we call a general plane motion. The translation motion is quite simple. We call it a translation if the line in the body, it remains to parallel to its original line. Okay, so if it moves, and then the line between the 2 points on the rigid body is still the same, it doesn't change in angle, so this is what we call a translating motion. If it's moving along a straight line, so this is called rectilinear. But if it moves up and down, along a curve line, so this is what we call a curvilinear translation. As you can see here, the line in the body remains parallel to the original line, and throughout the motion lah. Well, sometimes it will turn, right? You don't know if it turns like this and then it returns to its original pose. So this is not a curvilinear translation lah. For it to become a curvilinear translation, throughout the motion, the line have to be parallel along at every time of movement. So this is a translating curvilinear translation. But then what about rotation? So we define a rotation when all the particles of the body will be moving along a circular path about a fixed axis. So this is what we call the axis of rotation. It is a line, and all the points on the body will be moving in a circular motion around that line. For example, if we look at this from the top, and these are your points, and this is your rotation axis, which is a dot lah if you look at it directly from the top. So all the points will be moving in a circular motion lah. Sorry, my drawing is very bad, but it should be exactly a circle lah. Terrible drawing. Okay, exactly a circle. Okay, around that axis of rotation, except the points will lie on the axis of rotation, meaning the points exactly on this line, which means it's exactly at the center here, because if it rotates, nothing will happen, right? A point having a rotation, nothing will happen. And as I mentioned before, if a body undergoes combination of translation and rotation, is what we call a general motion, general plane motion. So your translation will occur within reference plane, and the rotation will occur about an axis perpendicular to the reference plane. What this means is that a plane motion is when the motion happen on a plane, meaning you can imagine, like for this slide, it's a paper, so your body here is moving on this paper. It's translational and curvilinear motion, meaning it's just rolling on the paper. However, the rotation, for example, you see it is rotating the line here. It rotates from this angle to this angle. So what is direction of the axis of rotation? It have to be a line here. It is moving like it is stabbing on the paper, meaning it is from you looking at this slide and then moving towards to the back of the slide, right? So the rotation will happen at this angle around this axis of rotation. So this is what we call perpendicular. So if this slide, if we look at the sides, so this is the slide, so this will be your axis of rotation, so it is a perpendicular angle. So for now, we only consider movements on a same plane, because if we want to include a more complicated plane, a complicated movement where there is a combination of the thing rotating and translating and then changing the angle and then translating again, the movement will be very, very complex. So actually it is something that you have to learn on the later chapter for dynamics lah. But for this course, we're only going to touch until plane movement, which means, as I said, your movement are only restricted on a paper lah. You can imagine it is only moving on a paper, the translation and the curvilinear on a paper, and there will be a rotation along a fixed rotation axis that is perpendicular to the paper. Okay, so looking at this, for example, so you can see that there are various type of movements lah. Actually, you can imagine like there is a motor here, so the motor is rotating this circular thing here, and this link and joint here is fixed to that ring around that motor. So as the motor turns, this will turn together with the links, and what will it will pull, and the movement of this piston here will be like this, right? Because the movement is only on a straight line, so this is what we call a rectilinear translation. But this link here, how will it move? It will move, will be being pulled by this ring, and then return here, go back here, return here. So it will be moving with a change in angle and also a change in position on a curvilinear translation. So this is what we call a general plane motion. And of course, this ring here will be rotating about a fixed axis, so it's a rotation. And here also, although it doesn't turn 360 degrees, but the movement is only on along a fixed axis. And here it's written a curvilinear translation, because if you simulate this movement, this line here, it will not change. It will move like this, maintaining this angle. So it is a curvilinear translation.